Hello everyone, so let's talk about flatten binary tree to linked list. So you are given the root of a binary tree and you have to flatten the tree into the linked list. So a linked list should use the same tree node class or blah blah blah, that would be easy. And so you are given the tree, right? And you have to return a linked list tree. Okay, so what you actually need to do is you have to convert every left subtree to right subtree. So here's a recursion case. So think about it. How do you actually do? So what you actually need to do is when you're going down to your children, you still need to flatten, right? So there are two cases you cannot avoid, which is flatten, root.left, and flatten, root.right. Okay, these two cases are not are definitely needed, right? So I'm going to starting code for the tree node left. So I'm going to remember my left and right tree node. So what would I do for right now is I have to set the left to a node. Since I'm taking care of the left and right every single time on a single root, right? Because I actually traverse every single root, right? Because flatten root at left, flatten root at right, at some point I will hit on the basic one, right? So the base case is if root equal to null, you just return. So that's simple, right? And now at the bottom, I will definitely know I have to make my left to null and my right equal to left. Okay, super clear, right? So imagine you are at here. Just imagine you are at tree node 2. So I set to the root.left to null and root.right to 3. So the 4 is temporarily gone, right? But I still have a variable. So I'm going to say tree node p equal to root. So initially when I add here, the tree node p will become root. And I would say, well, p.right is not null. It's not null. P equal to p.right. Okay, I spelled it wrong. So what this actually mean is, since 4 is not here, right? So 2.right, which is 3, and 3.right is nothing, right? So I break out the value, but after I break out the value, I have to say p.right become right. Why? Because I already stored the value for tree node 4, right? So I just have to make sure. So the diagram will become 1, 2, 3, 4, 5, 6. And when you go back to the top, so you're still doing the same idea. Tree.left is 2, tree node right, which is 5, and you make your left side to null and right side to left first, and then you traverse. Yes, you traverse through p.right, and just at the end you just connect to the right, which is 5, connect to the 4. So that will be the solution, and just run it and you will see what happens. And yeah, easy peasy, right? So what do you think about the time and space complexity? So the time would definitely be O(n), right? Traverse every single root once. And well, for the value, you definitely need to keep going, probably N square, but you just do the half of the tree. So value you will re-loop half of a tree. So I'm going to say N square. N. All right, N. So okay, N square. Okay, come on. And for the space complexity, so tree node left, tree node right. What do I actually do? For every single node, I create a left and right tree node. So if there's a tree node, it's 2n. So 1, 2, 3, 4, 5, 6. there are 6 tree nodes, and each tree node needs extra 2 tree nodes, which is 2 to learn, right? So that would be all of them for space, and then n square for time, and that would be the solution. M times n, yeah, 2n. So sorry, n squared, n times n to the n, right? And that would be the solution. And good luck.